Hello, class. There's a couple of things I want to show you here for this lesson here about the trigonometric function. So we've got this unit circle to help us out with special angles 30, 45, 60, 90, and all the way through here. These are all accounted for, but what do we do if we've got like an angle we want to get the sine or the cosine or any one of the 6 functions for, and it doesn't sit perfectly on one of these spots? Well, for instance, 15 degrees. So show you some things about this. Your calculator operates in 2 different modes. It'll operate in radian or degree mode, and you select it when you go to this mode option. So right now degree is selected. So let's stick with degree. And I want to know what's the sine of 15 degrees. So this is interpreted as degrees because that's the mode we're in. So it's giving me the sine for this angle, 15 degrees, a little below the 30-degree angle. So, all right, so we would round it to whatever decimal place is necessary. Now, if I want to get readings on my calculator in radians, then I'm going to select the radian mode. And now if I were to ask for sine of 15 again, it's going to give me a different answer because it's interpreting it as radians, right? So always make sure you're in the right mode for what purpose you're calculating. And if I wanted to get remember that the sine, the inverse function of the sine was the cosecant. So if I wanted to get a cosecant, and let's say I want to get what's the cosecant of, we'll say pi over 7. It's not on here, right? So if I want to get the sine of pi over 7, I'm going to take pi and divide by 7. Okay, and since I'm in radians, there's the sine of pi over 7. Now, if I want the cosecant, I'm going to have to take 1 over that. So I could just say, oh, what is the cosecant? Well, it's 1 divided by the sine pi over 7. Okay, so that'd be my cosecant. And for cotangent, you're going to take 1 over the tangent, and for secant, you're going to take 1 over the cosine. Do not mistake these inverse. This up here is called the inverse sine. That's got a different purpose that we're going to look at later in the semester. What it'll essentially do is we'll feed it a sine, and it'll tell us what angle operates at that sine. So for now, we're just interested in sine, cosine, tangent, and then to get the inverse function that's associated with it, take 1 over that. Okay. Okay, the other thing I wanted to discuss is that there's this last theorem at the end of this section, and it's telling us that even if I have a circle that's not the unit circle, if it's in standard position with its center at the origin, then its equation is going to be x squared plus y squared equals r squared, r being the radius of that circle. And since it's something other than 1, to get the sine of an angle that's measured in radians, we're going to have to divide it by r, whatever we find r to be. And then the inverse relationship is still going to be there. So to get the cosecant, I'll just flip the r over the y. And to get the secant, I'll flip the r over the x. And then the tangent just involve y and x and the cotangent. So that won't really matter what r is. However, if we're told that we've got a function and we want an angle theta that runs through a point on the circle 4, -3, we want to find all 6 trigonometric functions. Okay, so we've got, what happened there? Just a sec. Sorry, I don't know what happened. So we've got a circle. And this origin is the center. Doing my best here, sorry. And then the point is 4, -3, so that's going to be putting it somewhere here. But what we don't know is what's the radius of this circle. So we're going to calculate the radius, and because of the distance formula, or because of the equation for a circle, and we can calculate this to be the square root of 4 squared plus -3 squared. So that would equal the square root of 16 plus 9, otherwise known as square root of 25 over 5. Okay, so we now know that the radius is 5, so we can plug it in here and calculate these. So since this coordinate was 4, -3, for instance, the sine of the angle theta is going to be equal to y over r, so that's -3 over 5. The cosine of theta is going to be x over r, so 4 over 5. And the tangent of theta, theta is the angle that runs through this point, so it's going to be this angle here. Okay, so that's what we're calling theta. And the tangent is going to be y over x, so -3 over 4. Okay, so these are a little more friendly to find their PAL functions here. So the sine has the cosecant buddy, and that's going to be -5 over 3. And this has the secant, so that would be 5 over 4. And the cotangent is going to be -4 over 3.